All right, section 3, open sentences. Let's go. Okay, so first we're going to start with an open sentence. An open sentence is a mathematical statement with one or more variables. So 6n plus 7 equals 37 is a mathematical statement. So solving an open sentence is the process of finding a value for the variable. And that's what we're going to do a little bit of today. So then a solution, the value that when replacing the variable makes the sentence true. So the process of finding it and the solution of an open sentence is after you find the value. So that would be like x plus 4 equals 5, x equals 1 would be the solution. So the open sentence and the solution. So an equation, a sentence that contains an equal sign. I hope I don't need any examples for that. Replacement set. This is a little new. A set of numbers for which replacements for a variable may be chosen. So, for example, you'd have like use 1, 2, 3, and 4 to find the solution for n plus 2. So they'd want you to insert this one, then this one, then this one, then this one. A set is a collection of objects, often shown using brackets. You just saw this a second ago. So it would look like that. Numbers inside of a set of braces. Sorry, braces, not brackets. An element is each number in that set. So each one of these would be considered, this would be a 4-element replacement set. So a solution set, made a solution set. A set of elements from the replacement set that makes the open sentence true. So in the last one we had, you would have had to use the number 3 was the element that would have made it true. An inequality is an open sentence that contains the symbol is less than, is greater than, or is less than or equal to, is greater than or equal to. And something I've said a couple of times, how I read these, I don't think about, the different stuff. I read down the left-hand side. So I go is less than. That's how I would read that. And the other one, if I did, let's go the other way. Let's do it this way. Never mind, did it again. Less than or equal. That's how that would read that. And here's just a couple other things of what that could look like. All right, so use a replacement set to solve an equation. So find the solution set for 4a plus 7 equals 23 if the replacement set is 2, 3, 4, 5, and 6. So we're going to replace the number 2, and they did this all in a nice graph, which is nice and pretty. So they replaced the number 2 for 4a plus 7. 4a plus 7 equals 23. That equals 15. That's not equal to 23. I replaced the number 3. 4 times 3 is 12 plus 23, or plus 7 equals 19, so that's not equal, so false. 4 times 4 is 16 plus 7, is that equal 23? Yes. So that's true. The other two will come out false as well. So the answer is the solution set for this would be in brackets 4. Find a solution set for 3 times 8 minus b equals 6 if the replacement set is 2, 3, 4, 5, 6. So again, we're going to insert each one of these in. We're going to substitute in for b. 2, we'll come over, just 2 times, and then we'll solve that really quick. 18 is not equal to 6. 15 is not equal to 6. 12 isn't equal to 6. 9 isn't equal to 6. 6 is equal to 6. Check. That was an evil one because they made you do all of them to come up with the answer. But if they give you a solution set, you do need to try all of them because you could have something later on with multiplication where 2 values could be the answer. So in that case, a solution set would actually be like 3 and 6. And usually makes such much better braces. Yeah, whatever. Moving on. Pause this one. Give it a shot. All right, so we're going to try each one of these. I guess the easiest way to do it would be sideways here. So if I went 6 times 0 minus 5 equals 7. That would go to negative 5 equals 7. Nope. So I'd be like, not correct. 6 times 1 minus 5 equals 7. That would go to 6 minus 1 minus 5. 6 minus 5 would be 1 equals 7. Nope. So this would be 6 times 2 minus 5 equals 7. That would go to 12 minus 5. 7 equals 7. Check. So I'd go 18 minus 5. Just went 6 times 3 in my head here. 18 minus 5 would be 13, does not equal to 7. I've also got a pattern here, so this would be 18 is not equal to 7. So the only answer is going to be 2. All right, same concept, punching them in. 6 times 0, or sorry, 4 times 0 minus 2 equals negative 8. And I can distribute that, so it'd be 0 minus 4 equals negative 4, or actually 4 times 0. I'll solve it in here first. Negative 2 times 4 would go to, so that go to negative 2, 4 minus 4 times 2. 4 times a negative 2 would come out to negative 8. So that's at least the one. 0 seems to be that one. If I did a 1 in here, this would go 1 minus 2. 1 minus 2 would go to negative 1 times 4 equals negative 4 equals 8 is not there. So that went to negative 1, that go to negative, or go to 0 times 4 equals 4 is not equal to 8. So zeros are only 1. We'll keep going. All right, use order of operations to solve this. So we're going to have to solve the left-hand side to get this number equals k. So first we're going to take the original equation. We'll first do the things in parentheses. So parentheses first, then exponents on the bottom. And we'll multiply and simplify here all in one step here, try to speed up the process. So 50 minus 10 would be 5. So divide the solution is 5. Your turn, go. All right, so I'm going to rewrite this up here. 3, 6 plus 4 over 21 minus 10 minus 6 squared equals W. All right, so let's do stuff inside first. So 3, and that would be 10 over 21 minus, let's see, and here would be 4. Keep my squared. From here we're gonna multiply this one out. So 3 times 10 for 21 minus 16 now. Now let's do these really fast. 30, 16 of this there is going to be 5. So that'll be positive, negative, everything's still positive. So that's going to equal 6. All right, real world example. So Carlos needs $35 or more for a fishing trip. He has already bought a ticket for the charter boat for $13. Carlos needs to save $20, $21, $22, or $23 to have enough money for the fishing trip. So the solution set for this would be S is how much money he needs to save, plus 13 that he already has needs to be greater than or equal to 35. So if the replacement set is these. So first we're going to replace S and S plus 13 with each value of the replacement set. So we're going to punch those in here. 20 plus 13 comes out to 33. Is that greater than 35? False. 21 plus 13 comes to 34. Nope, but we're getting closer. 22 plus 13 comes out to 35. Is greater than or equal to 35? Yes, we have one answer. And then 36 will be a second answer. So now we're going to have two answers in our solution set. So the solution set is going to be 22 and 23. Try this one and go. All right, so he needs to make $75 or more. For a shopping trip, he already has a sweater for $22. Does he need $51, $52, $53, or $54 to have enough money for this shopping trip? So S plus 23 greater than or equal to 75. So if I go 51 plus 23, 51 plus 23 is 74. 1 plus 23 is not great. It comes out to 74 equals 75. So I'm going to speed through this here. 52 plus 21 would be 75 equals 75. So that one's true. 53 is going to come out to 76. And 54 is going to be 77. So there's going to be 3 answers in here, 52, 53, and 54 would be my solution set. Well, 23. I goofed here. 23. So 23, so that one's not. So 53 and 54. Keeping going. All right, outdoors. So a 4-wheel drive tour of Cañón de Chelly National Monument in Arizona. I should have tried going there. Oh well. Cost $45 for the first vehicle and $15 for each additional vehicle. How many vehicles can the Velo family take on a tour if they want to spend no more than $100? So we're going to make that first into a mathematical statement. So they already have $45 for the first vehicle plus each vehicle, V, plus 15. So 45 plus 15x, or V, or whatever letter they have. And it has to be no more than $100. So is less than, or is less than 100. Right, plus 15n is less than or equal to 100. So plan, since there's no replacement set, we're going to estimate to find that value for a replacement set. So we start by saying, they say 6, so 6 cars. See if we need to go up or down. So we're going to substitute 6 in here. It's going to be 45 plus 90. 45 is 120, so we're going to need to go down a little bit. So we decrease the value. So we're going to try going 5, and then 4, and then 3. And this person, you can see how this one was done. They tried 5, still ended up being too high. They went all the way down to 2. Well, probably too low. This one's almost there, and that one's too high. So the solution set of 0, 1, 2, and 3, 3 vehicles is the closest they can get to having, to being closest to 90 without going, or closest to 100 without going over. So they can take 3 vehicles, or 1 vehicle plus 3. So make sure you check that out. Just because the n ended up being 3, that's not the answer to the question. That's the answer to what is n. But that doesn't answer the original question, was how many vehicles can they have? Well, they have 1. It's for 40. This would be for the first vehicle, and this would be for all the others. Guess I probably should have written that up here. First vehicle, the rest. So 1, and then 2, 3, 4, 5, 6, 7, whatever number they can have. And that's all we got.